Can you solve this Olympiad math question? Now, it looks kind of complex, but it's actually very, very simple. In fact, this question you're seeing on the board, we're going to solve it using just normal substitution. Now, the question says that if x to the power of 10 plus 1 over x to the power of 10 equals 2 root 5, then x to the power of 20 minus 1 over x to the power of 20 gives us what? We don't know. But we know x to the power of 10 plus 1 over x to the power of 10. So how do we know the power of 20? Now, we're going to do this by substitution. It means that we are going to express this in terms of x to the power of 10 plus 1 over x to the power of 10 because we know the value of that. So let us try to express this in terms of this using algebraic identity, like with help of algebraic identities. But before that, let's try to rewrite this power. We don't like power of 20. Let's write it as the power of 10. So we can rewrite this as, we can say x to the power of 20 is similar as saying x to the power of 10 to the power of 2 minus 1 squared is to give us 1, okay? Or x to the power of 10 to the power of 2. Because according to the law of indices, 2 times 10 gives us 20, so we haven't done anything wrong. So now we can rewrite this as x to the power of 10 all squared. Since they have the same power, can bring them together like this, all squared. Now we are getting there. This right here up does not have squared. We should have used our substitution directly here, but here is having a square and here is not having a square, and here is even addition, here is subtraction. So what do? We have to simplify this further, okay? Now, this looks very, very familiar. Where are we seeing this kind of expression from? We have a square, we have subtraction, we have a square. Yes, this is from difference of 2 squared. This is actually a difference of 2 squares. Now we're going to use the alpha beta identity for that. So we know that when we have alpha squared minus beta squared, it's the same thing as alpha plus beta, alpha minus beta, difference of 2 squares. So we know that identity. We're going to use that here. So alpha here is x to the power of 10. So we can write this as x to the power of 10 plus 1 over x to the power of 10, then x to the power of 10 minus 1 over x to the power of 10. Alpha, beta, this is our alpha, this is our beta, the same thing, okay? So yeah, we're getting close because now I can see this right here. But yeah, we should have done our substitution already, but we're having subtraction here instead of addition. That means we have to simplify this again. We have to express it and rewrite it in terms of the addition of this, not subtraction. So what do here? We have to use algebraic identity also, alpha beta expansion. We have to use that also. So to make it simple, let's use alpha instead of x to the power of 10. So that's alpha minus beta. So what identity can we use? How can we simplify this in terms of alpha plus beta? Now, because the identities that we know, right, contain squares. But this here does not have any square. Look at it, does not have any square. That means we have to introduce square to this if the identities were to be helpful to us, okay? So how do we introduce square to this mathematically? Because we can't just do it anyhow. Here's the trick. We can rewrite this as alpha minus beta all squared. Then we take their roots. We can write this as alpha minus beta all squared, and we take the roots. Don't forget, square cancels roots, and we still have alpha minus beta. We haven't done anything wrong, okay? So we still have alpha minus beta here all squared. Now, we can use identity also to expand this, okay? So when we expand this, we're going to have square root of, don't forget, alpha minus beta all squared is an identity that we should learn also, okay? So alpha minus beta all squared will give us alpha squared plus beta squared minus 2 alpha beta. Yes, that is an identity, okay? When you factorize this, okay, you're going to have something like this. Now, we should have it done here, but we're having squares. Don't forget, we don't need any square. We have to simplify this further. Before we substitute, we don't need this square. We have to simplify this further. We're also going to use algebraic identity also, okay? So yeah, now we have alpha squared plus beta squared. We can also rewrite this as We can also rewrite this as square root of alpha squared plus beta squared will give us alpha plus beta all squared minus 2 alpha beta, then minus 2 alpha beta right here, 2. Okay, so now we have simplified this to this. Now, going further, we can now say that this would give us square root of alpha plus beta all squared. Then when you subtract this, you have minus 4 alpha beta. Finally, we can say that we have finally expressed alpha minus beta in terms of just alpha and beta, then plus. Okay. Now, what I've done here is not actually add. So if you are new to algebraic identities, please let's check it online. Okay, let's go online and check it. We have a lot of algebraic identities that we can use for expansion and factorization. Okay, we have to learn some of them. You have to put them in our head by memory. Okay, we have to learn them by memory so we can use them right here. But if you want to know more about them, don't forget to subscribe to my channel because we're making videos on these different identities that we can learn. Please subscribe to my channel as a way of supporting me. Now let's move forward now. So this right here, alpha minus beta right here, and we can see here, we have expressed it in this format. So we just use direct substitution, right? So we can now express this in this form. Anywhere you see alpha, we put this. Anywhere you see beta, we write this. Okay? Very, very simple. Let's follow that. It's going to be very, very long. So let's do it like this. So alpha to the power of 10, x to the power of 10 rather, 1 over x to the power of 10. Now, so we're going to be having square root of substitution, square root of, we'll follow this, x, okay, let's put bracket, x to the power of 10 plus 1 over x to the power of 10, all squared, minus 4 times x to the power of 10 times 1 over x to the power of 10. Yes, that's by using direct substitution. We have written this as this. We are getting very, very close. We can simplify this further. This cancels this. So we write this as x to the power of 10 plus 1 over x to the power of 10. Oh yeah. Let's continue. That will give us square root of, I haven't made any mistake. Square root of x to the power of 10 plus 1 over x to the power of 10 all squared minus 4. Finally, you can see that we have used algebraic identity to express this in terms of summation of x to the power of 10 and 1 over x to the power of 10. Can you see that? That's the basic idea there. We don't know the value of this. We need the value of this, but we know the value of this. This we don't know. We express it in terms of this. So this right here is exactly this. Now we cannot get our final answer by substituting directly. Okay. So anywhere we see x to the power of 10 plus 1 over x to the power of 10, we impute 2 root 5. Okay. So now by direct substitution, we can have this as 2 root 5. Okay. Then times square root of 2 root 5 all squared minus 4. So let's simplify this further. Now we're going to have, okay, let's continue like this. We're going to have 2 root 5, open bracket, square root of. Now 2 root 5 squared gives us 2 root 5 times 2 root 5. 2 times 2 is 4. Root 5 times root 5 is 5. Okay, so 4 times 5 is 20. 20 minus 4. So this also will give us 2 root 5. Then 20 minus 4 is 16. Square root of 16, which is what? 4. Therefore, that will give us square root of 16 is 4. So 4 times 2 is what? 8. That will give us 8 root 5. Therefore, x to the power of 20 minus 1 over x to the power of 20 gives us 8 root 5. Final answer. Very, very simple. It is not hard. It's just a matter of wisdom and manipulation. If you know you enjoyed this video and you learned something in this video, please and please subscribe to my channel as a way of supporting me and learning more mathematical content like this. So very, very easy. Till I come your way next time. Bye bye.